In this video, we're going to discuss how the Earth's and the Sun's relationship causes changes in the length of our day and how it causes changes in our seasons throughout the year. In space, Earth is rotating on its axis. So our planet spins around once on its axis every 24 hours, or one Earth day. And with this, we're also orbiting around the Sun. And it takes 1 year, or 365 days, for us to make a complete orbit or circle around the Sun. So Earth is doing two things simultaneously. It's rotating in one spot while also orbiting around the Sun in a circle. Because it's orbiting around the Sun, we're going to have half of Earth being lit up by sunlight, while the other half of Earth will be dark. It'll be nighttime on the other half. And the separation between the light half of Earth and the dark half is called the circle of illumination. This circle is just everywhere that's currently being lit by the sun's rays. But because the Earth's axis is tilted, it's not going straight up and down, but instead it's tilted a little bit, it's going to cause seasons. As we orbit around the Sun throughout the year, we'll have times when certain locations will be tilted towards or away from the Sun, which is going to affect the angle of sunlight, as well as how long of daylight we have each day, or how many hours of daylight do we get in our 24-hour day. Depending on where we are on the planet, what latitude we are, so equator versus poles, we're going to get different angles of sunlight. At the equator, sunlight's going to come down at a perpendicular angle and hit directly at the surface. This is going to concentrate a lot of sunlight into a small area, causing areas around the equator to get really warm. But as we increase our altitude from the equator towards the poles, the angle of the sunlight is going to change. Now, instead of having a 90-degree angle between the sunlight and the surface, now our sunlight's going to come in at a less steep angle. So around the poles, it might be at a 30-degree angle instead of a 90-degree. Here, this is going to cause each ray of light to spread out over a distance. So we're going to get less sunlight in these polar areas, which is exactly why our poles are so cold. They're just not getting enough sunlight to warm them up because of this low angle of sunlight. So on our planet, we're going to have 4 distinct seasons. They're not super obvious in Florida, but if we lived a little bit further north, we would have cold winters, warm summers, and kind of middle springs and autumns. But the reason why we have different seasons throughout the year is due to that tilt of Earth's axis. When we are in our summer months, the northern hemisphere is going to be tilted towards the sun. So the northern hemisphere will get more sunlight and it will be warmer. That's why it's warmer in June than it is in December in the northern hemisphere. But if we were to look at the Earth during winter and our location around the sun, then we'll see that the northern hemisphere is tilted away from the sun and the southern hemisphere is tilted towards it. This is going to cause the southern hemisphere to be warmer and the northern hemisphere to be colder, leading us to a winter here. But in the spring and the fall, the way that the axis is tilted isn't going to cause one hemisphere to get more sunlight than another. Instead, both the north and the southern hemisphere will get equal amounts of sunlight, so we call these arc equinoxes in the spring and the fall. Both hemispheres receive equal amounts of sunlight because it's not tilted towards or away from the sun. There are 4 special days throughout the year between the Earth and the sun. And with these, they're going to be on different days of the years depending on whether it's a normal year or a leap year. But in the summer, we have our summer solstice, and this is in the middle of June. And with our summer solstice, we're going to see that because the northern hemisphere is tilted towards the sun, that the most direct rays hitting 90 degrees at the surface are going to be at the Tropic of Cancer, which is a line of latitude that is 23.5 degrees north of the equator. So at the summer solstice, the northern hemisphere is tilted towards the sun. We're getting more sunlight in the upper hemisphere, making it warmer. We're going to see the exact opposite in our December solstice. This is going to happen around December 21st. And now, because it's winter, the northern hemisphere will be tilted away from the sun. The southern hemisphere will be tilted towards the sun. So the area that's getting direct sunlight is going to be the Tropic of Capricorn, which is found at 23.5 degrees south of the equator. So the winter solstice on December 21st, the area of the world getting the most sunlight is 23.5 degrees south of the equator. But we have two equinoxes each year as well. We have a spring and an autumn equinox that happen around the 22nd of March and September. For both of these, because of the axial tilt, neither the northern nor the southern hemisphere will be tilted towards or away from the sun. Instead, it's going to line up so that both hemispheres receive equal sunlight. So at the equinoxes, both hemispheres receive equal sunlight in March and September. If you're a person that learns a little bit better with table form, especially when it comes to studying and remembering some of these subtle differences, you might want to use this slide to study before the quiz and the exam for this chapter.